Welcome to Non-Contact Meters. Our program today is on the model NCMP-603 Economical Portable Ultrasonic Transit Time Flow Meter. Today, installation and training. Quick review of our program today. Introduction. The Non-Contact Meters Inc. NCMP-603 is a handheld portable ultrasonic transit time flow meter. Very economically priced for your budget. Perfect for your water, wastewater, full pipe applications for pipe sizes 1 to 48 inches. We're going to touch on the theory of operation, specifications, programming, installation, typical applications, and the economics. First off, theory of operation. Let's use this as an example of transit time technology. We have a river and the flow is going from left to right. The man would like to cross the river in a rowboat, but as he goes down the stream, he's carried across the river to the other side, and he goes very fast because he's going with the current. But as he comes back across the river, he's going into the current, which makes him take a longer period of time to transit the river. Transit time. So the differential from the time going across the river with the current versus the transit time coming back across the river, which take a longer period of time, is the coefficient we use to derive on how fast the river is going. The greater the differential, the faster the river. So if we were to use this analogy, with this pipe right over here, this would be a bird's eye view, and unlike the man with the rowboat, he would be over here. In this case there, we're going to get lazy. We're going to put one sensor here and one sensor here and ricochet off the back wall just because it's easier to see and easier to do and easier to install. So in this case there, this sensor sends a sound burst across the pipe, reflects off the back wall, comes downstream to this sensor. We measure how long it takes. Remember again, flow is going left to right. The sensor on the right hand side here, it's going to at the same time send a sound burst across the pipe here, reflect off the back, come downstream here, and because it's going against the current, it will take a longer period of time to transit the pipe. The greater the differential, the higher the flow rate. And this is how it works. Now the positioning of the ultrasonic transit time flow meter obviously plays a role because we're measuring the transit time and the distances between 2 points. The position that we just looked at here has different names. It's basically the V configuration or the dual path configuration, or as this model, we're going to call it the dual crossing configuration. This is traditionally used in applications on this particular meter, say from about 1 inch to around 12 inch. It's also relative to pipe conditions. Down over here, this is the man in the rowboat configuration. We traditionally use this for larger pipe size applications where you need a little more power here. This is called the Z configuration, the single path, or as this model calls it, the crossing from these 2 points there. This is traditionally used for this flow meter around 12 inches or longer or larger, or pipe applications where you don't quite have enough straight run of pipe or have the 50-year-old crunchy pipe wall of a sound poor conduction. And some small pipe applications where we need to have multiple bounces here, we'll call this the W configuration, or we'll call it the 4 crossing or 4 path configuration. The placement of these transducers are calculated, so if this sensor wasn't in the right place, it would bounce and go off. So this plays a role in the programming and the calibration of this device. Now another key thing with ultrasonic transit time flow meters is that they do require some straight run of pipe for optimum performance. The magic number for a symmetrical flow profile is your traditional 10 and 5 or 15 pipe diameters between elbow to elbow for flow rates that are around 10 feet per second. Don't know your flow rates? Well, generically speaking, most pipes and pumps are sized for around 7 feet per second velocity. So that's just your rough gotcha there. So 10 feet per second is typical unless in most applications. There are other applications that go higher than flow rate, and if you had higher flow rate, you'd need more straight run of pipe. Lower the flow rate, you have less straight run of pipe. And on a symmetrical flow profile, what you're trying to achieve here, because you're between the two elbows there, the flow has a chance to optimize in that it will have these elliptical shapes, faster in the center and slower near the pipe wall. This might look down view of a guy in a motorboat going down a river with the wake cast out on the side there. These different shapes are defined as Reynolds numbers, and they will change their elliptical shape based upon the flow rate. What is important for this particular technology, that if you were to draw a center line down this pipe, the top half of flow equals the bottom half of flow. And that being the case there, 15 pipe diameters between two 90-degree elbows, you'll have a symmetrical flow profile. Now the opposite of that would be this, an asymmetrical flow profile, where you have an elbow in an application, and my flow is going up this elbow here, and you notice this distance is shorter and this distance is longer. And you're going to get a tumbling effect right here after the 90. If you were to put your transit time flow meter here, you're very likely to get no data as opposed to erroneous data. Go down 10 pipe diameters, plop your sensor there, have another 5 on the other side, and you're good to go. So ultrasonic transit time flow meters, unlike an ultrasonic Doppler flow meter, are designed to work on clean liquids. Now our definition of clean liquids is ultra pure liquids with nothing, jet fuel, deionized water, distilled water, sewage, but it doesn't work on sludge, slurries. What's a slurry? Let's use the word oatmeal. Okay, lots of solids like that. That's where the Doppler works there. So bulk of the applications you're going to find are going to be any aqueous base application. Water, oil, conductivity doesn't play a role. You have a full pipe, then ultrasonic transit time flow meter is great for that. You have an application that has oatmeal in it, then that's more suitable for an ultrasonic Doppler flow meter. So water-based applications, perfect. Anything aqueous, energy management, HVAC, chemical processes, you can imagine everything. Water, wastewater, everything except sludge, irrigation, and more. As far as applications, it always happens. You get in your car and you drive 100 miles to go do a flow survey, and this is the application you find. And there's no straight run of pipe, and the customer says, hey, I just want to see it read. Well, if you want to just show it read wrong, then you'd put it here. It wouldn't read anything. When you have a bad application, you have to walk away from the application or put the bottom line in. You got to have enough straight run of pipe. So you may have to go before, you may have to go after this application, upstream, downstream, and somebody may actually have to pull out a backhoe to get this device to work properly. Even on a perfect application, we have lots of straight run of pipe there. You may have some applications that have some serious insulation on the pipe. You will have to remove insulation from the pipe itself there. So this particular case has a metal shielding on the outside of the insulation. So the maintenance people may have to actually prep the pipe for you. You may not have the tools in your toolbox to take this off the pipe there, and they want to put it back on pretty. If you have the foam installations, of course, it's a lot easier there, but it has a lot of straight run of pipe, but take into account what you require to actually get to the pipe itself. You may require scaffolding and ladders, or you may have to remove insulation off of piping to get your good application. So what is in this kit? The NCMP-603 comes as a complete kit. So for the $4,800 price, you got everything ready to go. Open up the box, you're ready to go to take care of your application business. So inside this kit, you will get the handheld meter itself, and you'll get underneath here a set of transducers for pipe sizes 1 to 48 inches. You will have transducer cables. You will have a power supply, a USB cable, 4 to 20 milliamp cable, a logging software, the carrying case itself, which is a weatherproof carrying case when you button it up. The transducer mounting kit, which would be the alignment bar, the clamp, stainless steel straps, and acoustic couplant. So you're literally ready to go outside the box. Of course, there'll be an operation manual in there as well. The hardware. Well, this is the handheld ultrasonic transit time flow meter itself. And as you can see, it's about the size of, say, a big voltmeter. And navigation is done through these buttons here. We got navigation arrows and a check mark in the middle. On, off, you can turn the backlight on and off. And it also has a sleep function. This particular meter under battery operation will run up to about 18 hours. Should you need to run this longer and do a long-term log, say for about 3 days, you can actually put it in the sleep mode. So in this case, what it will do is it'll take a reading, go to sleep, take a reading, go to sleep, and then you could extend the battery life to about 3 days. It also, of course, has a line cord which you can plug in and then plug it in and trickle charge it and do your logging for however long as you want. The log itself, you collect up as high as 300,000 data points. So you have plenty of storage room as well. This particular device, as we said, is designed for applications that are clean liquids, things that are less than 2% suspended solids, aerations, or solids. You can program the device to read in English, French, and Spanish. The electronic enclosure is ABS plastic. It is not a weatherproof enclosure, so you need to put it in the big suitcase if you need to leave it out in the mud. Has a big bright display, which even I can see with my glasses off. You can the outputs are 4 to 20 milliamp. As I said, it does have a logger. It does come with a piece of software for the logger. The operating temp for the handheld electronics is traditional, -5 to 140 degrees F, and on the metric side, -20 to 60 degrees C. And the plastic carrying case itself, the suitcase, is rated to IP67 with foam inserts. Moving on to the hardware of the transducer itself. The transducer, which they come as a pair, in this case they are 1.2 megahertz. Again, transducers with each brand of transit-time flow meter are unique. So they're not interchangeable. They have their different frequencies and different angles. And so you have to buy them as a pair because they're matched. So I said these are good for 1 to 48 inches, same set, and they're perfect for any rigid plastic or metal pipe. It does not work well with flexible hoses because their shape is nondescript. So we need the math is not there to do something that's not perfectly round. Flow range for this equipment is basically from 1/10 of a foot per second to 40 feet per second. It is a bi-directional technology, so you can read to the left, you can read to the right, you can read to the positive, you can read to the negative. Operating temperature of the transducers is -40 to 300 degrees F, which is also -40 to 150 degrees C. The mounting kit includes we're going to use the transducer and these clamps. These clamps right here are like stirrups. And you'll see in the next picture there's actually a stainless steel hose clamp goes through there, and the transducers get put in here, and the end of the clamps here is the same dimension as the end of the transducers, which you can measure the differential. So you strap these stirrups on and you plop these sensors right inside that stirrup there. So relatively quick to put them on the pipe. Standard, you get 12-foot of cable with quick disconnect connections there, and you comes with a tube of grease, and you're all set to go. Now, one really cool feature with the transit time, this transit time flow meter, is that you actually have the ability to test the functionality of the device when you're off the pipe. Sometimes we get a call from support, and they'll say, you know what, our flow meter doesn't work, and after review the whole thing, it's application related. So wouldn't it be nice to know whether you had a broken cable or you had a bad application? So if you put in an application that didn't work, you can take it off and do this test. This will validate you don't have an equipment problem. So it just gives you that peace of mind. You basically, through this procedure, you mount the two sensors face to face and set up it with these programming parameters, water and the spacing and so on, and the number of crossings, and it will define whether the device is functional on the bench test off the pipe. It's pretty cool. Here's a picture of the installation we were talking about. So we have these stirrups here. We have the stainless steel clamps, and so basically this little alligator clip here, the transducers pop in and out over here. Do note, versus other transit time flow meters, this particular design, the cables are on the inside. Everybody else has their cables pointing on the outside. So different technology there. So as you can see, this picture is actually wrong in that it's at 12 o'clock. We prefer not to put the sensors at the top of the pipe. Device has a lot of very interesting status icons, and so we'll just tippy-toe through a few of these. This is the case. We'll show you all the battery performances, whether the logger is on or off. It'll also show you about your USB file status. It'll also show you if the echoes are acceptable based upon the recommended crossings. It'll tell you about empty pipe or no echo symbol. So and then also tell you when the no sensors are attached. So very informative device without reading the manual. In the manual, of course, is a flow chart, and this is basically the methodology to use to program the flow meter. Nothing really unique. You just put the pipe statistics, the application statistics in, and it gives you your spacing, and away you go. So when all else is lost, you don't really need to read the manual to operate this meter, but this is the pathway to program the device. It has a very bright run screen. If you don't press a button fast enough, you get lazy and just leave it on there, it will go back to the run screen itself, and it will basically display the units, the flow rate, velocity, or totalization. On the message screen, this will tell you the status of the data logger, the amount of log used, the amount of battery that you have left, the charger's on or off, and the sensor condition. More about the battery. Said it's good for about 18 hours. The total recharge time, if you're going to run it dead completely, would be about 6 hours. So if you use the thing for a whole day or a couple of days, best probably to plug it in overnight to get your full charge. Also in this menu screen there's another status screen there. Will tell you the status of your velocity and your signal strength. So in this case there, the first question we ask you from support, and if you're not getting a reading and you did your transducer test, is what is your signal strength? And most commonly the meter is programmed incorrectly and the two sensors aren't saying hello to each other. Special feature with the logger screen, you can actually scroll down to get daily information up to 365 days. That's when it's stored in the meter. So more logger information, kind of interesting for a very economically priced ultrasonic transit time flow meter. And of course, for those people that are concerned, it has a password function. So if you want to leave something out on the field and you don't want your neighbors or big brother to come by and change any of your parameters, you can lock it out with a password. So let's navigate this device and set it up for a traditional application. So the main screen, of course, pops up, and when you go in there, you press the right arrow. This will bring you to the password screen, and you can go from the password screen to the menus itself. After that, every device you have to program it for the units that you're going to work in. So in this case there, we're going to select English or metric. In this case there, we want to read the flow in inches, or we want to use our engineering unit in inches, or you could read it in metric if you wanted to. We want the volume in this case to read in US gallons. And as far as the time factor, you can read it in seconds and days and hours. So most people select gallons per minute. And then we move again to the setup. And in the setup function now, we're actually going to go and select the type of transducer, which is the SE16B. Then we're going to select the flavor of liquid. In this case there would be water. So when you go and you select fluid water, if you want to change that, there's a drop-down menu to a whole bunch of different flavors of processed liquid. Then if you have something exotic, there's an other function. And if you have something exotic, the default that I use is the specific gravity of other products. We do provide you with a very elaborate sound speed chart for different processed liquids, so pipe material and processed liquids. It's also available up on the website. It's available for anybody for free. And then again, if you have something proprietary, you can give us a call because we have other lists that aren't published to point you in the right direction how to discover what the sound speed is. But for most of you, 99% of the time, it's on the drop-down menu and it's no big deal. And in addition to that, you'd also have to take into account if you had mixture, say water and glycol there. So keep that in mind. We may have to calculate the sound speeds in if you have a ratio of certain glycol and certain water and so on. Fluid temperature, you pop in there, pipe OD. Pipe outside diameter is the most common mistake that people put in the pipe. We give you an ANSI pipe chart book. Please use it. When you say you've got a 4-inch pipe, you don't punch in 4 inches. You go to the pipe chart book, or you go and take a tape measure or string and wrap it around the pipe, divide it by pi, 3.14, only thing I remember from high school, and you'll have your pipe OD. If you have the wrong OD, it'll give you the wrong spacing. Pipe wall thickness, we have thickness gauges that you can buy, you can rent, but in most cases, not necessary. If you use the pipe chart book, you're usually just fine. Again, 95% of the time, you've got a Schedule 40 pipe, carbon steel. If you've got a copper tube, type L is the most common, and use the ANSI pipe chart books for this. Again, anything special on that, you have the ability to calculate that out. Look to the left, look to the right, look at fittings inside the pipe and pipeline that you're working with, which will pretty much tell you what size pipes you're working with here. If you had a different pipe material, again, pipe material, this is selected PVC here. You can do any rigid metal or plastic pipe. There's a long drop-down menu. Select that. Again, if it's exotic, there's another function. We can help you out with that. But again, that's going to be a rarity. If you had a ductile iron pipe, then you might have a mortar lining, or you had a rubber lining. You need to accommodate that again in the drop-down menu. The crossings will be detected and advised to you. So based upon the data that you put in, it'll give you a certain amount of crossings. The zero tear is zeroing the meter, don't touch. No need to re-zero your flow meter for your basic applications. Just stay away from that. Then it'll spit out your sensor spacing. So for this particular application, we have a sensor spacing of 2.59. And it also has some signal strength rating. So in this case there, the sensor spacing at 2.59 is the differential from here to here, which is, notice here's your nice mounting clamp. It's just like a stirrup. The sensor's under this big alligator clip here, and the back side of the transducer and the clip are the same. So this is your differential that you'd have for that particular application. Now note, this is pictured for your view at 12 o'clock, but as we move forward here, we want to keep the device off of 12 and 6 o'clock just in case you got air and in case you got bubbles here. So on the larger pipe applications, we have to go to a Z configuration. Again, one would be at 9 o'clock and one would be at 3 o'clock. Again, the transducer cables are on the inside of this distance here. And when you go to the single path, single crossing, or Z configuration there, the distance will be about half between the two transducers because you only have one path going across, 180 degrees across from each other. Not as easy as this here. Now remind you, the beam is about the diameter of a pencil. So you need to take this sensor, put it on the pipe, find 180 degrees on the other side, mark it off, and be on the same plane and the same transaxial angle here for this guy to work. More pictures about the transducer. Vertical, we don't mind. Vertical versus horizontal. Again, on the vertical, we're going to make sure we're square on the pipe there. And anything that's off of 6 o'clock is no good, and 12 o'clock is no good. So we need to put that on the pipe. People always talk about how much grease do I put on the outside of the pipe. Well, toothpaste on a toothbrush is my answer. The pipe is round, and the transducer is flat. You don't need to take a grinder to the surface of the pipe. We're just trying to remove the loose debris off the top of the pipe. And yes, of course, the insulation must be removed off the top of the pipe. Why do you need grease? You need grease because it is an acoustic pathway. If you're swimming in the river and off in the distance there's a motorboat and you hear it, but then go dunk your head underwater and it sounds like the motorboat is right on top of you. Well, it's because the sound travels faster through the solid than it does through the open air. So in that case there, put your grease on your pipe. Take note of your temperature. There's different flavors of greases there for different applications, long-term, short-term. So we have other selections for you to take a look at. Navigating the logger, well, again, to do the logger, we're going to go back to the main screen through the password and under the menu selections, and this time we will select data logging. And under data logging, we will go ahead and set the date. And unlike some of the other loggers, it actually has a date that you can understand. Set the time interval and set the sample interval. Now the sample interval, this is programmable from 10 seconds and more. Now remember, we said we have 300,000 data points, but you do get a ton of data if you're taking samples at 10-second intervals. Generically speaking, if you're just doing a flow study on a normal application, most people tend to take a snapshot once a minute, which will give you 1,440 data points in a day. The software accommodates this, and it will accommodate the 10 seconds there. But if you export it to Excel, you get 30,000 data points, and Excel begins to get pretty muddy. So sometimes too much information is too much information. So we select the sample interval, and you do have the ability, based upon how long you're going to leave it out there, for wrapping the data. If you wrap the data basically after your 300,000 data points, it can rewrite over the data if you don't want to pick up the device and let it keep going in a loop. Most people will not wrap the device. Select logging, and the device will begin to log. We will provide you with a piece of software and a USB cable that you plug into your laptop or PC to say hello to this meter. And basically, to work the logger, when you use the software and plug everything in, it'll go through a discovery process, and you'll select the scan mode for the USB instruments, and then in the main window will detect this particular meter. Click the download icon to start the transfer of data, and then a downloaded data will appear, and it's a pop-up window, as you can see down over here. And what you're going to get is a spreadsheet and a graph. And also you can export this data from this software program to Excel should you like to do that as well. Coming in the future, of course, Noncontact flow meter is infamous for their dedicated transit time flow meters and energy meters there. The portable meter we're talking about today is in the design stage here, so in the future you'll be able to take the output of this device to also tie it into a BTU system. And to monitor BTU, you'd basically take the flow meters itself, and they would monitor flow on the supply line, and then they'd monitor two temperatures, one on the supply and one on the return line, and collect all that data to give you a BTU calculation. So available already with the NCM-E series, to be available with the portable device in the near future. And just here's a picture of the technology. It's basically an interface that's going to have two strap-on RTDs, and we can do temperature with strap-on RTDs. We're not looking for the actual temperature, we're looking for the differential between these two temperature sensors there. So there are some rules on how to mount them on the pipe. It works great on metal applications for BTU, not so much on a plastic pipe application. You don't usually do BTU with plastic anyway. It does require a power supply for operation. So a little bit about us. Well, you've heard of Instrumentsdirect. Well, Noncontact meters is their manufacturing arm of Instrumentsdirect. And basically, Noncontact meter has over 35 years of experience in ultrasonic transit time flow meters, and puts together for everybody the NCME, which is the dedicated ultrasonic transit time flow meter, and now the portable NCMP-603 ultrasonic transit time flow meters. And of course, we design and do some engineering for a lot of other ultrasonic meter people in the marketplace. Should you like to get information about our program today, it is available at noncontactmeters.com. You will find on this website data sheets, you will find contact information, and of course training videos and operation manuals. Questions and answers. If you do have any additional questions about this technology or non-contact meters, you can give us a call at 770-516-3999 or drop us an email at sales@noncontactmeters.com. Thank you for attending our program today.